And we're going to look at two methods today, algebra methods. The first one's called substitution. And try to write small because we're going to need some room on the left for our second method. Now, we're going to be on the left at the beginning, right here, but then we're going to do another strategy on the right. So let's try to save some room. So the letter U is usually used is traditionally used for substitution. Other letters that you might see used, probably not in this class, but in calculus you will. Others used are V, maybe Z, etc. Now, the only one I ever really saw in calculus was V. You might use two different substitutions, a U and a V. Why wouldn't we use X or Y? They're already being used. Very good, very good. So we'll do one example. Substitute and solve the system. Alright, so in Frank's class, you worked a little bit with systems, and you actually did systems in 3 dimensions with an X, Y, and Z. We're just going to look at two, an X and a Y. So here's your system. Set it up. 2x plus y to the negative 5 over 2 equals 6. And 3x minus 2y to the negative 5 over 2 equals negative 5. Just negative 5 over 2? Okay. If you do that, how many variables do you have? You have 3. What's a better U substitution? Y to the negative 5 over 2. So a better U substitution here, and some of you guys were talking about this, is U equals Y to the negative 5 over 2. It's the whole thing. Exactly. And in this case, it's not only a better one, that's the only way it will allow you to solve. So it'll be 2x plus U equals 6, and 3x minus 2U. We have 2 of them. Equals negative 5. Now we look at this. Are we back to Frank's class now? You have a system. You have 2 ways to solve systems. Substitution and elimination. What's a better method for this context? I think elimination's easier. What letter do you want to get rid of? U. We're going to manipulate this top equation, right? Multiply by 2. Multiply by 2. Very good. Yeah, there's a lot of U jokes. Alright, let's go ahead and multiply this. We get 4x plus 2u equals 12 over 3x minus 2u, which is equal to negative 5. This comes out real nice. Yeah, the u's cancel. They eliminate. So we're left with 7x equals 7. So x is equal to 1. Now, are we done? No. X is equal to 1. Now we got to consider the problem, right? We're solving this system. Do I care about solving for you? Alright, so we're going to go back and substitute. Pencils. Actually glad we don't have bells. So nice. Okay, so most of you probably can make it here, and we've dealt a lot with complex fractions, especially in the exponent. How do I take care of that? Not square root. Let's keep it as a fraction. Reciprocal. What's a reciprocal then here? Negative 2 over 5, negative 2 over 5. These cancel. So get your calculators out. 4 to the negative 2 over 5. I think you end up getting 0.57. So you get 1 comma 0.57. That's your x, and that's your y. That's our final answer. Yeah. And I'm going to look at the example you guys just looked at and what Sarah drew, so you'll have it in your flip book. So let's say we have our rectangle. And Sarah, you said you did you divided it up four in each place, right?
Yeah.
That allowed you to divide it up evenly. Then how many squares do we have at the bottom? 16. Okay. What it's allowing you to do is visually see what's going on with the algebra. So what you didn't notice probably in the blocks that were given is this block has 2 dimensions. It's x by x. And if you want to find the area of this box, we do length times width, right? And we get x squared. Enrique, question?
Does this have anything to do with the golden ratio?
No, not the golden ratio. So this box is x by x. Now, did it give you the dimensions of these rectangles? I think it did, right? It's 1 by x, okay? So all of these are 1, so it's 1 plus 1 plus 1 plus 1. But you had 4 of them, right? So we can really just say it's x plus 4. And if we do 4 times x to find the area of this box, we will get 4x. And we will also get 4x here. Okay? Now, 48 connects this to the algebra. Why is this useful? Why are we looking at a graphical representation of it? Because actually, that's kind of the way I want you to think about it. Well, if I give you this equation, x squared plus 8x, how many tiles did we add? Yeah, we did y plus, now do y plus blank. That's what we're going to call it. X squared plus 8x plus blank. All of you added, well, most of us, we know Sarah did, added 16 small tiles to fill that in. Once we got these 16 small tiles in here, do we have a square now? And the beautiful thing about this square is you can factor this. So I don't even want you to look at the left. I want you to deal with the right and factor it. Okay, before I factor it, why do we add 6? If I add 16 to one side, why is it on that other side too? Balance, right? Otherwise, it's not a legal move. Okay, who's got the factored form of this for me? Brittany. Got it. X plus 4 times x plus 4, x plus 4 squared equals y plus 16. Okay. Get that y alone. Move that 16. All right, go ahead and box this. Y's alone. Do you recognize that form?
Down 4 and to the left 16.
We're going to the left 4 and we're going down 16. Good. Is this your vertex form? Is this a lot more helpful for us than x squared plus 8x? Yeah. In Algebra 2, you learn completing the square, but you don't learn why. Now we're using it as a tool to make our lives easier, kind of like substitution. Okay? Okay. Do you have questions on this? The question is, how do we move from this, because this is all we're going to be given, to this, without drawing out all these rectangles? How do we get from 8 to 16? Because that's the only thing that's changing, right? Yeah. Mm-hmm. Why? Now let's talk about why we divide it by 2. What's happening with the rectangles? Well, we started originally with a total of 8, right? Why are we cutting them in half? Because we need to make a square, and a square is even, right? So we're dividing it evenly, and then what do we do after that? How do we get 4 to 16? And why are we squaring it? 4 times 4 is 16. Okay? So this is, memorizing what to do, right? It's connecting to why we do it, though. Okay? If you want to draw the rectangles, great. But it does become really tedious. So I would suggest you guys writing this down. B over 2 squared is how you complete the square. You take B, cut it in half, and then square it. And that will give you your blank. Okay? Here it is. Complete the square. To find the center and the radius of the circle. So now we're going to connect this a little bit with trig, and I know we introduced the unit circle equation, so it's going to be very similar. So the unit circle equation, you might remember it's x squared plus y squared equals 1, or r squared. That's the equation for a circle. Now, the form we want to move into, it's a little bit more complex. This is just a little context. Looks like this. This is a circle centered about the origin, no shifts. If you want a circle with shifts, meaning it's not at the origin, it'll be x minus h times y minus k. And we'll get to, that's kind of where we're going to end up going. So here's your equation in standard form. When I used to teach conics, this used to be one of the problems on my tests. X squared plus 6x plus y squared minus 4y equals 51. This is a really messy equation. Now, believe it or not, this is a circle. You're going to use completing the square to put it in this form, find your h and your k shift, which is going to be your center, and then find your radius. This is your final destination. Look at this, though. You have an x and a y right now, right? So we're going to complete the square how many times? Twice. So I'll set it up for you, and then you can do it. Because actually, the completing the square is the easy part. X squared plus 6x plus blank plus y squared minus 4y plus blank equals 51 plus, how many blanks do I need? 2. Plus blank plus blank. Alright, so you should have 4 blanks. I'm going to let you guys take it all the way. Complete the square on the x and on the y, and put it in that final form, find the center and the radius. You get 9, very good. So the first blank you get 9. Alex Roscoe, what do you get for your second blank?
Second line was 4.
4 and 4, good. Okay, Kelsey Vasquez, give me the factored form for the x's. Perfect. And Julissa, give me the factored form for the y's. Very good. And Sarah, this is all equal to?
64.
Perfect, which is actually a really nice number for us. So the center of my circle, you need to be careful with this. I haven't taught you conics, which is fine, but this is why I was so big on, when I taught you H and K, not just thinking, oh, it's, the Lyre is a decent way of looking at it, but I rather think the opposite. This parent form, both of them are the opposite, right? Because they're both negative. It's not just negative h plus k, it's negative h minus k. So which way are we going with this 3? To the left, and which way are we going with the 2?
Sorry.
We're going up. It's the opposite. So our center is at -3, 2. And our radius is not 64. And why is it 8?
That is r squared.
Yeah, r squared is this number. So to find r, you square root it. That will give you the radius. So now you know exactly where the center of your circle is. -3, 2. You can plot it, and then with a radius of 8.